Hello everybody and welcome back to another Apex Rollup walkthrough. Today I am excited to talk to you about unit testing Apex Rollup within your Salesforce org. Now this is not a required step by any means, but if you are interacting with Apex Rollup through Flow or through Apex itself, you have the option of setting up unit tests for yourself within Apex. Of course, if you're interacting with Apex Rollup through Flow, you may also prefer to use the new Flow tests interactive GUI to create your unit tests there. This walkthrough will be specifically concerned with creating those unit tests within Apex itself. Now, one of the reasons why I really love working with people who are using Apex Rollup but are also writing their own unit tests is because in a unit test context within Apex, both the synchronous part of Apex Rollup, which runs during a trigger invocation, for example, and the asynchronous part, which by default happens using a queuable, get collapsed into one context. And specifically, this ends up being really helpful when identifying regressions for me in the event that I don't have sufficient test coverage within the package itself, because the log file that gets generated contains all of the information instead of being split out into perhaps a log file on the Aura side from, let's say, the full recalculation app, then the log file that gets generated for the queuable. Having all these things in one nice package is such an amazing tool, both for your own debugging and for me in the event that there is some kind of issue. So with that being said, let's get started. Today we're going to be working explicitly in VS Code. I'm going to be walking through the process of setting up these unit tests. Now, I've made a couple of updates from the Apex setup video, which was specifically geared more towards admins using Apex Rollup using that one line of code invocation. In this case, I've made some crucial changes that are more familiar to the Salesforce developer who's looking to install Apex Rollup in their own org. Specifically, you can see I've updated the opportunity trigger that I showed off just within the UI before. Now, instead of calling Apex Rollup directly, there's this layer of indirection. There's an opportunity trigger handler being used. And this is a very, very simple trigger handler. In this specific case, we are going to end up doing that same one line of code, rollup.run from trigger, but it's going to live in this opportunity trigger handler's overridden and finally method. So one of the things that I'd like to talk about is the difference between true unit tests, which are going to be trying to avoid the database as much as possible and trying to avoid querying as much as possible, and something like an integration test. And an integration test in this specific case will involve validating, for example, that the opportunity trigger correctly calls Apex Rollup in, at the very least, the three contexts that we care about at the moment, which is going to be after insert, after update, and before delete. So with that being said, let's get started. I've created a little shell of a test class that we're going to be operating in. And I think it'll be nice to start off with something like that classic integration test. Now, in this specific case, we're going to, again, start small and try to iterate on the concepts that I'm showing off so that we can build up a full suite of tests that provide the coverage that we need and the confidence that we want for the individual rollups that we have set up. So I've pulled the custom metadata for the 5 rollups that I've been using in each of these individual walkthroughs. But initially for our integration test, we just want to write something, again, that validates that the trigger handler is properly calling Apex Rollup in each of those specific trigger contexts. So let's get started. I'll start by creating my test method. And for this one, I want to say it properly calls Apex Rollup. Now, I've gone back and forth about using camel case and snake case with test naming conventions, In this case, I'm just going to try to build something that's as readable as possible. Recently, I've been preferring camel case for test naming conventions, but let's just go with the snake case because it makes it easier to read for now. So in this specific case, what I really need to do is set up an opportunity. I need to update it and I need to delete it. Now, I could do those three things in individual unit tests, but because we're going to also be covering what I'd like to refer to as like a true unit test, which isn't really using the database that much, I'd like to get everything done for this integration test in one go. So let's give it a go. Create my new opportunity. Of course, since we're going to be inserting it, we're going to need a couple things that we wouldn't otherwise need to set up. But for example, the stage name is required, close date's required, name is required, and it'd be nice to have an account ID. In this case, it's not exactly necessary. So actually, let's get rid of that for now. Now let's get some fast feedback by just saving this, making sure I didn't forget any required fields. All right, so that's deployed. Let's run, make sure there's no issue so far. Great. Okay, so the first thing that we need to do is access a test visible private static variable that's accessible off of the Rollup class itself. So this is called cached Apex operations. And what we'd like to validate at this time is that the after insert context has been called. So this variable cached Apex operations is actually a map of schema.SObject type to a set of trigger operations. So what we want to validate right now is that the set only contains after insert. We use the new assert class. And we're going to be accessing this by the opportunity SObject type static variable. But prettier sort of formatting. Run the test and get that fast feedback. So there we have it. Now, the integration test speed, it's not amazing already because, again, there are triggers involved, there's DML involved. But let's keep going on this one. Next thing we want to do is continue down this front. And this time, let's also include after update in there. So we've updated the opportunity. Now we want to make sure that the set properly reflects that Apex Rollup has been called in the right context following that update. Let's see how that impacts the runtime too. Should be pretty interesting. I don't do a lot of integration testing these days, so it's always interesting for me to see. All right, so the runtime is about the same, and I think what that tells us is that there's some startup cost involved with interacting with the database, and after that it's actually pretty performant, which is good because there's really not that much happening in the opportunity trigger handler at this exact moment. Now finally, let's delete the opportunity, and I'm going to copy this for now, and then I'm going to fix it, because when you have something listed twice, that's usually okay, but by the time you get to 3 times, it's typically an indication that there's an opportunity to consolidate things there. And there you have it. So the 3 trigger contexts that we care about have now been properly validated. Apex Rollup is being called in all of these examples. And what that means is that we can move into more of a unit testing mindset moving forwards, because we don't need to integration test the trigger handler itself, the opportunity trigger itself. But before we do that, let's try to clean this up a little bit. So I'll create a set here of trigger operations, and we'll call this expected operations, and we'll start off with our after insert, because that's what we expect to have there. And now here we can say expected operations.add, and we'll just add after update. This is expected operations, and here don't forget the semicolon. Pretty just gonna unwrap those lines since they're below now the max column width that I have set up here, which is really nice. So this test, in addition to getting a lot shorter, it's a lot less repetitive now. We'll rerun, make sure we haven't broken anything. Awesome, and move on with our lives. So it's time to get started with the really exciting stuff, I think, which is doing the unit testing for each of these individual rollups that we have set up. Now I'm looking at these custom metadata names here, and I can see the first one is concat op name to account. Just going to go in here, make sure that actually the custom metadata name is properly reflecting the way that this has been set up. And in particular, what I want to look at is the rollup field on the calc item. So yes, indeed, it is using the opportunity name. That's good enough to get started. So let's do our first unit test. Concatenates names to account. And actually, let's see. I mean, it's basically the API name of that field being set up, so I'm not going to worry about it too much here. So Apex Rollup exposes a bunch of test visible private static properties that can end up being used to simulate a run from a trigger or a run from a flow. And in this case, I'm going to show you the fields that you need to set up, and I'm going to show you what you can use either in your own tests or in conjunction with the code coverage plugin that Apex Rollup provides as an additional smaller package that can be installed. So if you're not using that extra code coverage plugin, and in fact you're writing these unit tests to generate the code coverage that you need for the package, that's perfectly fine. But there are some things that we're going to want to use. And for example, one of those things is a method that I'm going to have off in another directory here. Right now we'll just refer to it as testing utils, and the method is going to be generate ID, because we want to try to simulate records being inserted, being updated, all that good stuff. So in the beginning, what I'm really trying to think about here is, given a certain set of inputs, what is the expected output? And in this case, the set of inputs that I want to look at are opportunities, and specifically opportunities that have different names, and maybe even some of the same names, to show that for a strict concatenation, not a concat distinct operation, we're not going to distinctify the rolled up field. So let's get started. I'm going to have a list of opportunities, and I want to go really light on the fields that are required here. So the thing that I'm interested in right now is just the name. So let's say set up 3 opportunities. I want to show you basically without actually using any of the additional static properties that Apex Rollup exposes, what in an ideal state I'd like for this test to look like. So for example, the thing that I'm really looking to do is call rollup.runFromTrigger. That's my act method. I've done my arranging here. This is all that I really care about. And finally, I want to assert on something as well. And so in this case, actually, maybe what I need is a parent level record that I can represent as an account in this case. And here I'm going to start to use some of the testing utils methods that I was talking about. So in this case, we're going to do generate ID. I'm going to pass in account.SObject type. That's all I really need there. And I suppose that means that on each of these opportunities, I will also want to set the account ID. So I'll multi-select. And I'll add in those properties for each of the opportunities. So now I'm free to, I've done my arrange again, I've done my act, which is rollup.runFromTrigger, and now I want to add in my asserts. So ideally what I'd like to see here, based on the account field, is one, two, three. That's my expected concatenation string, and I want to compare it to, and here I need to go off and refresh myself on what this API name is for the field. So concat all op names. So this is the arrange act assert test that I'd like to write. But there are a couple things that are missing that I need to tell Apex Rollup about. And the first thing that I need to do is tell it about the records that I'd like for it to process, as well as the parent record or records that will be keyed to those opportunities. So in this case, I'm going to start by making a new helper method within this test. We'll call it run test. We're going to need to pass the account as our parent. We're going to need to pass the list of opportunities. For update and delete tests, we're also going to need to pass the old records map, which can be null for the insert test that we're running at the moment. And with that in mind, we're going to need to pass the trigger operation. So first things first, Rollup has this should run value, which defaults to false when Apex Rollup is not called from a trigger or flow context. We're going to override that and say, hey, look, you actually should run for these unit tests. It also has a static property called records. That's what we're going to set the ops to. We need as well to have IDs for those opportunities for some parts of Apex Rollup to work. So we're going to use this stub method called generate IDs, which if there is not an ID already supplied, will generate them for the list that we have passed in. So we have our IDs, we have our records. We also need to tell Apex Rollup that the stubbed parent records in this case is going to be isolated to an account that we're passing in. And because Apex Rollup runs by default asynchronously, we want to override that asynchronous approach here so that we don't have to actually use test.startTest, test.stopTest, and use a queuable or batchable job. So in this case, there's a property called specific control. I'm going to use an in-memory faked out version of a rollup control record here. And I'll set is rollup logging enabled equal to true to show you what that looks like. But crucially here, what I need to set up is the should run as text field. And there's a class called rollup meta pick lists. It exposes a property called should run as, and there the value that we're looking for is synchronous. So those are the only two values that we really need there. We also need to set our Apex context equal to the trigger operation that we're passing in, and that should do it. Let's give it a go, see what happens. We have to close here by calling run from trigger. So now we'll replace this run from trigger call with run test, passing the parent, the opportunities. For now, I'm going to pass null. If this becomes a pain point in the process of writing these tests, I will for sure create a overloaded version of run test where we don't have to pass the map value. And this will be that we're mocking our after insert context. So let's see what happens. And I'd like to say that this is a hopefully minimum of ceremony. All right, let's see. What did I forget? Stubbed parent records, stub parent records, not in the past tense. Cool. We're pushing, we're running the test. Let's see what happens. And look at that, we're getting feedback. And the interesting thing is that there is an actual value. It's not null, despite the fact that we haven't set up anything like DML mocking. The parent record in memory is being updated. The crucial difference here that I've forgotten when initially writing this assertion is that concat operations automatically alphabetize the entries. So update that. We run the test. And there, our unit test is passing. It doesn't have the best runtime right now. I've seen some higher than usual runtimes coming out of this Scratch org over the past couple of days. But the benefit that we are seeing here chiefly is that the amount of ceremony that goes into creating a unit test like this is extremely small. Look at how readable this test is, even in comparison to the integration test that we just wrote. There's an absolute minimum of setup. We are just providing a parent, we're providing some children records, and we're using that to validate that our custom metadata is set up correctly. So that part is still happening. That part is not being stubbed out in the system. We are validating that the result of our given rollup operation, which in this case is concatenation, is occurring properly. And we're also validating that there's no issues that we haven't foreseen by using something like is rollup logging enabled. What I mean by that now is I can go and look at the log that gets generated by this test, and I can use that log to step through and evaluate whether or not what I think is happening is actually happening when that log opens up. So if I use this user_debug keyword, and I can go through and inspect the different rollup operations that are being processed. So I can go through the entirety of this log, take a look at each individual rollup operation. I can say, okay, well, for this rollup operation, I can track exactly what's going to happen. We're going to get to the does op name contain keyword field, for example, in the rest of our unit tests. But I can literally step through and see how each of the fields starts to get built up. So here we can see, okay, this is actually from the test that we just wrote. And that's why I have isRollup logging enabled set to true here. So I can go through and look at that sort of asynchronously in the background. Well, let's get another test going now for our next rollup, which is the max of the opportunity's last modified date time. Now, this one is going to be a little tricky to mock because last modified date time is a system set field. Now, there are some ways around that. I've talked in various blog posts about how we might go about getting around that, and I'll show you here using a simple method how to set an audit field like that properly on a record without having to go to the database. So let's say it maxes last modified date properly. And now here I need to introduce another method, call it setReadOnlyField. We'll provide a schema.SObject field token. We'll take in an SObject record and we'll take in an arbitrary value type. And here, what we'd like to do is an unfortunate but necessary dance to append these values to the record properly. So in this case, I'm going to serialize the record, deserialize it into a map, and then reserialize it back into an SObject. So to begin with, looking at the deserialized record. So we'll do JSON.deserialize untyped. We have to cast it to a map of string to object. Our JSON string is actually the serialized version of the record. And then we'll say deserialized record dot put field token, get described, get name, and the value. And actually, instead of this being void, we'll return the new version of the record by also casting and going through the inverse of that same process. So now we'll say JSON.deserialize, JSON.serialize, deserialized minus record, our Apex type is SObject.class, and that'll allow us to stub out the last modified field on these opportunities. So let's get to it. We can actually copy quite a bit of the test above. In this case, you're just going to be also calling the setReadOnly field on these new opportunities. So we're going to say opportunity.lastModifiedDate is the field that we're looking to write to. And for this one, we'll do something far in the past, actually, as our last value. So we'll say now add days -5. And we'll repeat those steps here. So setReadOnly field, grab the last modified date. For this one, we'd like this to be the one that wins because it's in the middle, so we want to show for sure that the entirety of the max logic is working properly. And so for this one, you can say same thing, except it'll only be slightly into the future. And at the end of this, we want to be able to confidently say that the max that's properly being picked up is exactly the one that we anticipate. So it might be helpful as well to pull this value out into a variable that we can then refer to in our assertions. So I'll say date time, expected max, and now it's actually kind of nice because we can use that value to ensure each of these other values is definitively less. So instead of basing everything on system.now, we can create something that matches our expectations. So same thing, we'll do run test, and our assertion should be that the expected max equals, and let's get a look at what this API name is, max op last modified date time. Let's push and run. Once again, remind myself to annotate the method properly as static so it can be referred to in the test context. And I have to cast these records since they're coming back as the generic SObject type properly. All right, let's run the test and see what happens. Cool. Now, I also really like this phrase, never trust a test that you haven't seen fail. So what I want to do is ensure, for example, that making a change to the test that violates the expectations that we have ends up generating a meaningful failure. This is a bit pedantic, of course, because we expect that this is going to work exactly the way that it already is, but it's nice to be able to generate a failure. So just to show that if your expectations aren't set up properly, the test does indeed fail for the exact right reasons, and that's because Apex Rollup is properly finding the max regardless of which child record it's on. Cool. So that takes care of our first two operations. I'm kind of skipping around a little bit because I could also be showing, for example, the after update and before delete trigger contexts. Right now, I just want to settle for showing the minimum necessary, for example, to get these unit tests up and running. I think that conceptually, when you think about how these tests are being set up, it's easy for you to see how you might set up the update tests, but we're going to come back to that. I'm not going to cover the before delete tests here in this video since it's already starting to get a little bit long, but once you've seen how the insert and update tests work, I think that you'll see that it all starts to make sense as far as how you would set those up on your own. Now, you might not always necessarily feel like you need to do that if you're getting the coverage that you need through something like these integration tests and some of these more unit test related items. But that's just to say that once you've seen how the setup is performed for after insert and after update, it should be relatively clear what you're looking to modify in order to show whether or not something is working in the delete context as well. So let's keep going here. Add our next test. And this one is the min created date time. So unfortunately, we're going to have to revisit our setReadOnlyField friend to get this one running as well. But then we'll be sort of out of the woods and back to something that's a little bit more standard as far as these unit tests are concerned. So it minimizes CreatedDate. I'm just going to take this whole block at this point, update a couple of things, get that set up. So let's update these to be CreatedDate now. And here, now I want to remove the negative signs because we want to make sure that this expected max now is properly set up as the expected min. So the only thing that I need to do here finally is get the correct API name from the custom metadata as far as what my assertion is looking for. And let's push and run. Very exciting stuff. There we go. On to the next one. It counts opportunities at count level. Now I can go back to my sort of happier path test. Copy some of these things. And in this case, we're just looking for the value 3. Let's look at what the API name here is, count of ops. So that one should be much more simple as compared to the last two, right? Now for this one, there's actually a calc item where clause, which I've just found by looking through the debug log that was generated due to the test failing. And the reason that the count wasn't applied is because the stage name didn't equal prospecting for any of them. So this is actually a chance to set up another one of these more interesting tests where only some of the records need to match. So let's set the stage name properly for 2 of them and use that to validate that the where clause is being applied properly. Cool. And that brings us to the sum operation. And let's just make sure okay, there's no calc item where clause on here, so it's just a strict sum. Means move along here, grab a lot of the same stuff, and instead of setting the stage name, let's set a couple of amounts. Top You can do this a variety of different ways, right? You could just hard code 100. You could say ops0.amount plus ops1 amount. I think that in general, I always encourage a good balance between readability and not repeating yourself. In this case, I probably would be more tempted to just use the value 100. Hopefully it would be clear looking at a test this short where that 100 is coming from. But your mileage may vary, and of course you should be making these decisions in accordance with either what feels right to you or can be agreed upon by the people that you work with. So you're always trying to converge on something that makes the most sense. In the meantime, we can start by writing the unit test for this one and validating that it's set up properly. So this is it flags account as having third in the stage name. I'm going to move this record over to where I've kept my other custom metadata records. So let's once more grab our test data. Now here, we want this as what we're operating on. And let's just check that calc item where clause. So stage name includes the words need analysis. So we only need one of the opportunity records to have this be set up properly. So let's do that. Just clear out this other value. And for this one, I think it's important to show the negative version of the test where none of the opportunities actually properly match. In general, I am a big proponent of negative testing, in addition to doing the positive version that you expect. I think that for some things, you sort of get that negative test by default, like in the sum operation. Not having an amount value on this third opportunity means, okay, if it wasn't added incorrectly in this case, I'm not sure that there's a value in having another test where none of the opportunities have any amounts. But in this case, for something like a flag-based field being set, I think that there is some value in creating a negative version of this test. So it does not flag account as having third in stage name and no matches. And then set up our expectations accordingly. Cool. And now we've got our passing test for the negative case as well. So both the positive and negative versions of that test. We've got our integration test. In general, the test class itself is starting to look pretty robust. We've only handled, again, the after insert context at this point. So I'm going to run through one of these operations having a update context test as well. But in general, I think that it should be clear to see how you can quickly start to iterate on including these tests and generating the coverage necessary. And again, the confidence necessary to know that for your specific setup, Apex Rollup is doing exactly what you would expect. And I think this is really powerful because it, again, helps you and it helps me to identify regressions in the system in the event that I accidentally introduce an issue. I can't tell you how many times somebody's been able to provide a flattened down log that's the sum result of a test being run, and the issue is quickly addressed as a result. So I can go and see, okay, this is great. Everything's running exactly as I expect it to. Now, I think that the flag is an interesting case as well for showing off a update context where the negative case ends up being applied. So I want to take this test, create a copy of it for update. And in this case, I'm also going to be including for the first time this value, which is our old records map, and I want to use the first opportunity, but I want to create another version of this opportunity where I basically want to take this exact opportunity here, because I want to show that if the account is currently flagged as containing this needs analysis stage name, but the opportunity gets updated to no longer match, in that case, I want to be able to show that the account is properly updated back to having the flag as false. So you include the ID here again. And in this specific case, I'm going to have to generate the ID ahead of time so that it has that. So I'll have all of that information. And then lastly, I need to have the flag currently set as true on the account, because I want to show that when a record is updated to no longer match, so the old version matched, new version does not, that the flag is properly reset to false. So it disables flag on account. When no third in stage name on that. It's not the best test name I've ever written, but I think it gets the point across for now. I'm always open to feedback on a better name. So let's run that and validate that the parent record is updated exactly as we would expect because it no longer matches. And there you have it. Now, again, if I were to do any combination of different things here, if the flag was already set to false, the test isn't really proving anything other than maybe that there was an issue and the account wasn't flagged properly to begin with. But we can for sure generate a meaningful failure by just showing that if the opportunity does actually contain the values that we expect, the account isn't going to have its flag be set to false in an update context. So this is one of those situations where, again, you might benefit from having the positive and negative version of this test. I'm just going to show the negative one for now, but you could also do the inverse where this test was asserting that the flag equaled true when it started in false for the account. So an update made one of the children records qualify for that criteria to be met. So we'll rerun with the negative version of the test just to show that it will fail when the opportunity doesn't meet that criteria. Now I'll back out these changes by resetting the flag, getting rid of the stage name here, push, and lastly, once the push has gone through, we'll rerun to show that we're back to passing. And again, maybe I want to codify this expectation in a negative version of the test. So go back, sort of reverse again what we just did. And here we don't have a match. So at the end of this update, we expect that the flag will properly have been flipped from false to true. And again, as well, I hope that this shows how easy it is to iterate on these concepts when the arrange, act, assert model in conjunction with the run test helper method ends up funneling everything into something that's easy to read, easy to understand, and easy to run. So with that being said, I think we're going to end here for the day. Again, I'm not going to cover the before delete trigger context for these unit tests, but I hope that by showing off both the after insert and after update context, it's easy to understand how you would then go about creating these tests. I'm also going to be committing these changes and linking to the repository in the description for this YouTube video. I'd like to thank you again for coming along with me on this journey, and I look forward to seeing you next time. So thanks so much. Signing off for now.